again, if we can, we are going to factor everything we can first, because it will make our life a lot easier. If you factor wrong, you will make your life a lot harder. So factor first without making mistakes. That is a key to this. So the first one, I notice a difference of squares. This is x plus 7, x minus 7. I'm going to leave some space in case I need to add more to my denominator. And the second one factors to be x plus 7, x plus 7. Are they identical? No. This one is missing another x plus 7. So we multiply the top and bottom of this one by x plus 7. And this one is missing the x minus 7. Now, I have a common denominator. It's going to equal, I'm going to leave it in factored form. If you want, you can do that and say x plus 7 happened twice. I can write it as x plus 7 squared. Or I could just leave it as x plus 7, x plus 7, x minus 7. And if I simplify the first one, I'm going to get 7x plus 49 plus, and I simplify the second one, it'll be 3x minus 21. And now we can just combine our like terms. Again, I have to rewrite my denominator. But 7x plus 3x will be 10x. And 49 plus a negative 21 will be plus 28. But I notice that the top can be factored again. I can take out a common factor of 2. Multiplying and dividing was way more fun, wasn't it? Because you got to cancel out a whole bunch of stuff, and things went away. Adding and subtracting, ugh, you have to write so much extra. So now we check, are any of those factors identical? They're not, so we can't simplify. This would be our final answer, and I think your textbook lists the non-permissible values are negative 7 and 7. That is our final answer, simplified. Same thing in part B. I'm going to factor first. So I have on the top an n minus 3. I'm going to put that n minus 3 in brackets because that's one term. On the bottom, I'm going to factor. And I get n and n. It's going to need to be plus 6 minus 3. And in between, I have subtract signs, so I'll leave some space there. The second one, I have on the top an n minus 2. Put that in brackets to put together. And if I factor the bottom, it's going to be n plus 5, n minus 4. And something happens in this one that hasn't happened yet. Do you notice in the first fraction, you're multiplying that, and we have factored that identical. So you'd be able to say this simplifies. That's going to be huge for later on. If you can simplify within a fraction, your life is going to be a lot easier. This is, I mean, if I switch this back to numbers, sometimes when you're doing algebra, it's nice to say, how does this relate to a similar type of question in numbers? Okay? How would you add the following? 2 over 10 plus 3/5. What's your common denominator? Could be 10, or it could be 5. Because I could reduce the first one to 1/5. If I could reduce early, my life might be easier, because then I don't have to reduce later on. So in this one, you would say, hey, this is the same as 1/5 plus 3/5, and then I'm done. I've added them, and I got my compound. The same thing's happened here. This first fraction wasn't in lowest terms. But now we look, what are we missing? You see the second one is missing the n plus 5 and the n minus 4. If you hadn't canceled this out, You would have to multiply all three of those together, and you would get an n cubed. Not recommended. The second one is only missing one factor. And had you missed that you could simplify it out, you would have added the a minus 3, and you would have got another n cubed in the other one. And life would have been more difficult. So now we have our common denominator with the n plus 6, the n plus 5, and the n minus 1. It doesn't matter the order that you write. If I simplify in my first one, this canceling out basically leaves it with a 1. I still have n plus 5 times n minus 4. That's pretty easy to multiply out because we factored in the beginning. And had that in the beginning of the question underneath. Minus, and now we can multiply these out, and we'll get n squared plus 4n minus 12. Do we have any like terms? Yes, we do. If you ask yourself, oh, this is annoying writing the denominator every time, can I just skip it? No. Okay? This is probably one time that I will let you be annoyed with math, but you still have to be annoyed with it. You have to write it. Every time you write the next step, it has to equal the step above. So you can't just omit something because you're lazy and don't want it. No, you won't. On the top, n squared minus the n squared, that pulls away n. Minus 4n will give me negative 3n. And negative 20 minus the negative 12 will give me negative 8. That gets grouped together. Nothing is identical, so we would be done, and the textbook probably listed the non-permissible values are minus 6, minus 5, 4, and 3, even though it disappeared. It was a non-permissible value at some time, so you still have to list it. Okay, take some time. Circle questions 7, 10, 12, and 13.